Okay, guys. So in our last set of video notes, we were talking about similar polygons, and that could be any kind of polygon, doesn't matter how many sides it has. But tonight we're going to be a little more specific. We're going to focus on just triangles because in triangles there are some shortcuts we can use. In other polygons, we pretty much have to have every pair of corresponding angles be congruent and every pair of corresponding sides be proportional. But when I have triangles, we have some shortcuts, just like when we did congruency. Okay, so you'll recognize these initials. Um, our very first one is AA, and that stands for angle-angle similarity. And so we've got, and notice the word similarity. We can't just say AA. We got to make sure we differentiate about whether we're talking about congruency or similarity. And so one of the things that we know is that if two angles in a triangle are congruent to two angles in another triangle, well, the third one's going to be congruent as well. And all we really need to match up are the angles to be for the triangles to be similar. So 2 is enough. If I know that two angles in one triangle match two angles in another, we've got similar triangles, and that's AA. The second one is SAS. And just like it was in congruency, it stands for side angle side. And so what happens here is we still are dealing with two pairs of sides and the angle between them, just like when we had congruency. But this time we don't want those sides to be congruent. We want the sides to be proportional. So it states that in two triangles, if two pairs of corresponding sides are proportional, and the included angle, so remember we said that knowing what's included is going to be important. So the angle that's included, if that's congruent, then that means that the triangles will be similar. Okay, and so that's side angle side similarity. And because there's a side angle side congruency, we have to, this one's especially important that we differentiate there. And then the third and final one is side, side, side. And so the side, side, side similarity says, hey, if I know all three sides in one triangle and all three sides in another, I can check. And if those sides are proportional, so if I've got the same ratio going on there, then the two triangles must be similar. Okay, the angles will automatically match up. And that's the way it works. All right, so let's put it into action and let's see if we can determine if triangles are similar and decide what the reason is. And these are the only three reasons we have. So AA, SAS, or SSS. Okay, so we're going to look first at what if we don't have a picture? What if all we have are these side lengths? And so that for some people that may kind of wig them out, but it's actually fairly simple. All we're going to want to do is make sure that we match the smallest to the smallest. And we're going to write and see if these sides are similar. Because we've got all three sides, we should be able to check for side, side, side similarity. Okay, so in this first one, in triangle ABC, 4 is the smallest side. In triangle XYZ, 16 is the smallest side. And so we know if we reduce that all the way, it reduces to 1/4. So we want to check and see if that happens with every pair. Okay, so the middle sized side is 5 in ABC, and the side in the middle here is 20, and that reduces again to 1/4. And then the final, our largest side is 7. Largest side in XYZ is 28, and that would again reduce to 1/4. Okay, so because the ratio in all three sides, all three pairs of corresponding sides is the same, then that means we have SSS similarity. So we would say yes, they are similar. Okay. All right, so let's do the same process with number 2 here. And I want you actually to pause it. I'm going to give you a moment, pause it, take a moment, and check out number 2, and let's see if it works. Okay, so you should notice you should have these ratios, and notice it wasn't in order here, and so pay attention to what order it actually should be in. The smallest length in STU is 2, and so our ratios come out like this, and 2 of them will actually reduce to 2/1. So if you check those two first, you might assume, hey, yeah, it's going to work. But the third one won't reduce. It stays 3/2. And so we do not have three pairs of similar sides. We would say no, triangle PQR is not similar to triangle STU. Okay. All right. Let's go ahead and move right along. And let's see. Let's do some more. Okay. All right, and so this next one, notice we don't have any angles marked. So if they're going to be similar, it's going to have to be side, side, side. I don't know any angles here. And they don't share any angles. Sometimes that's the kicker. So let's look in triangle DEG, and let's look at our smallest side is 3. If I look in triangle EFH, then my smallest side length is 6. So we've got that ratio there, which we immediately should recognize as 1/2. Okay. So I want to check and see if the others have that same ratio. We've got 5 right there is the middle length, and over in this triangle, our middle side is 10. So yep, yippee skippy, we got 1/2 again. And then the final side to compare, we have EG there is 6. And we've got 6 and then 6 more, so 6 to 12. Once again, it's 1/2, so yes, we have similar figures, and we would write our statement like this. We would say it's triangle DEG, and we want to make sure we name them in the order that correspond. So D is between the 3 and the 5, then that means it corresponds with the one that's between the 6 and the 10. And so I'm going to look in here, and that would be H. Okay. And our E is between the 3 and the 6, the smallest and the biggest. So we need the one between the smallest and the biggest here. It would be between 6 and 12. That's going to be angle F. So we have a triangle HFE is how you would write that. Okay. And I want you to add one more thing, because what we use to prove it, and this is the big deal for the day anyways, I don't know why it's not on there, they're similar by side, side, side. So that's the reason we know they're similar. Okay, let's take a look at number 4 over here. This time I have absolutely no sides, so immediately I know if they're similar, the only way I can prove it would be by angle, angle. And so the first thing we notice is, hey, looky there, we've got 80 degrees and 80 degrees. So it's got one pair that's congruent. Okay. And then I want you to pay attention to where those triangles are. They're actually overlapping. Do you see that? There's the little one, and then here's the big one. Okay. So they actually have one angle that's in both of them. So angle X, whatever it is a part of both of them. So they have two angles that are going to match. So by angle, angle, we do have similar triangles. Okay, so we're going to say yes, and let's write our statement, and let's just go with X, W, V, and in my other triangle, the X corresponds with X. Those are the angles that are congruent. And then Z corresponds with W, so Z, Y. Okay. All right, let's look at number 5. This time we actually have sides and angles. So there's my clue that I'm probably going to want to try to use side, angle, side. And sure enough, it's the two sides on either with the included angle that we're dealing with here. So we've got a congruent angle, they're both right angles. And then we've got a 6 and an 8. We've got 18 and 24, so I want to check and see if these are proportional. 6 is the smaller of the two. It would match up with 18. We know that would actually reduce to 1/3, so the ratio here is 1 to 3. And let's check and see if the other one matches up. We've got 8 matching up with the 24, and that will reduce to 1/3. So we've got a pair of proportional sides, and their included angle is congruent. So by side, angle, side, we do have similar triangles. Okay, and let's write out their statement. We would say triangle QRS is similar to triangle TUV. And that one's pretty simple to tell how they match up because they're facing the exact same way. Okay. Number 6. This time we've got sides. We don't have all 3 sides. The KM's not given to us. The JN's not given to us. So we know we can't use side, side, side. We don't have enough angles to use angle, angle. So the only thing we can, so we know we're trying to shoot for side, angle, side. And sure enough, do you notice that they share angle L? Okay, so that's an angle that they have in common. And then let's match up our side lengths. So we've got LK is 6, and this whole side here from L to J is 9. 6 plus 3 there is 9. Okay, that would reduce to 2/3. If I look on the other side of the triangle, we've got LM is 10. And then the whole side length here of my big triangle is 10 plus 5, that's 15. And that would again reduce to 2/3. So we've got equal ratios, we've got proportional sides, and we've got their included angle congruent. So once again, by side, angle, side, we have similar triangles. Okay, and so we're going to write out our statement. We'll say triangle KLM is similar to triangle JLN. And one of the things you'll learn in our next lesson is that when this happens, that must be because these guys are parallel. Because if they're similar, we'll have the angles there that must match, and that only happens when those lines are parallel. So that's actually kind of a bonus there. All right, I want you to pause it, and I want you to try number 7 by yourself, and then you can unpause it and let it play and check yourself, see if you did it right. Okay, so hopefully you were able to notice that we've got vertical angles this time, and that's going to give us the congruent angle. And then we've got two pairs of sides, and sure enough, if you check them, they both have the same ratio. Be careful because this PQ actually corresponds down here to SQ. So when you write your statements, make sure you write them corresponding. But yes, they are similar, and it's by side angle side. And the way I wrote the statement was triangle PQL is similar to triangle SQR. And so just make sure if you wrote them in a different order, make sure P is corresponding with S, Q is corresponding with Q, of course, and L and R correspond. Okay. All right. Be ready to do some of these in class tomorrow.